Muy buenos días, gracias a todos por estar conectados nuevamente en sesiones online de Portal Odontólogos. Nos da muchísimo gusto estar conectados. Esta vez estamos conectados hasta Boston. Tenemos al doctor Álvaro Gracia y está conectado el doctor George W. Key. Welcome, doctor. Welcome, doctor Álvaro. Welcome, doctor George. La transmisión será en español. Bueno, algunas cosas estarán en inglés, pero bueno, las estaremos traduciendo para ustedes. El tema de esta mañana es primer adhesivo óseo y estará llevado nuevamente presentando al doctor Álvaro Gracia. Él es graduado de la Facultad de Odontología de la Universidad de Boston en 1994. Se unió a Advanced Dental Care of Norton. El doctor Gracia completó estudios avanzados de posgrado en odontología general, prostodoncia, implantología, odontología láser y sedación intravenosa y oral. El doctor George W. Key es prostodoncista y diplomado de la Junta Americana de Implantología Oral, Implantología y la Junta Americana de Odontología Forense también, destacado clínico y educador dental para una generación de dentistas y prostodoncistas. Welcome both, and I'll give you the microphone. I'll share your microphone. Welcome George, welcome Dr. Álvaro, bienvenidos a todos. Gracias por estar conectados. Adelante.
Welcome everybody. We're here in Boston with our topic which is about Tetra, the first bone adhesive. Es el primer hueso adhesivo and it's the next generation of the conducted resorbable bone adhesive. Material de hueso que se reabsorbe. Vamos a continuar con un video para mostrarles exactamente el concepto what the Tetra is about. I'm going to show you a video what the Tetra is about. Dr. Josh Kay.
Hello.
About the launch pad.
Hello, I'm Dr. George Kay, and I am the Chief Science Officer of the company that is developing this technology. It is something which is based on biomimetics. In other words, much of it is based on biology that exists in sea creatures which stick sand together to make their homes. But we're moving it over into human treatment, and I hope you find this very exciting. This presentation is just a small sampler of what we'll be showing in September, and I hope that you find it very interesting because very possibly this will change the way implant dentistry is done in the future. Next.
No, I'm going to show the video.
Dr. Gracia, I believe you had slide 2, yes.
Yeah. Es una mezcla que corta el hueso y se aplica en forma líquida y se pone las dos partes juntas. And then we put in the Eastern machine. Y se prende una máquina. Se hace el testing.
Doctor, could you please better explain the video? It and shut turn off your music. It's doesn't understanding anything.
Yeah, this is a cortical castle metathesis fresh line femur. And we use the Eastern, es a machine, el AT10, en el cual se va a separar los dos fragmentos. El fragmento se cortó muy suave y muy, los dos segmentos se unen compatible se une y se coloca el pegante, que utilizamos en este caso sería el tetronite, y se va a colocar en la máquina de strength para mirar la potencia de separación de los dos segmentos. Como ustedes pueden ver, es casi 250 libras para separarlo. La duración fue de 5 minutos para separar, y más que, sobre todo que cuando está en combinación con agua y sangre, en ese caso, pues la duración, el strain o la duración de separación sería más fuerte. Eso. George, want to add something?
Only that the material has robust strength, that we get 300 pounds, up to 500 pounds of force needed to break after 10 minutes of curing. And that same amount of strength is developing in our applications in patients to support implants in the jaws. Next. The technology is based on, as I mentioned, on something which is produced by living organisms. Both of the components are items that already exist in the human body. Tetracalcium phosphate is a calcium salt, calcium phosphate salt, and phosphoserine is a very common metabolite without which life would not be possible. It is necessary for example, for biosynthesis of heme and glutathione and serine, as well as glycine, amino acids in the body. And the technology also involves adding some additives to produce the bone adhesive. But basically, the fundamentals of the technology are the tetracalcium phosphate, the phosphoserine, and water. Those are the three primary constituents. And we can go to the next one. There are many items or many products available now for the making of bone grafts. They vary from the autograft to bone morphogenic proteins, to synthetic materials, to xenografts, demineralized bone matrix, allografts, and all these products have as a goal to fill bone voids. Many of them have issues. Some of them migrate from the field of application. Some of them are not injectable. Some of them do not maintain volume. Most of them do not have strength to support loads. And many of them either do not have any resorption, or resorption rates don't match the clinical need. The material that we're developing, on the other hand, is one that has a clinically relevant rate of resorption. Next, please. This is an example from many years ago, actually, of the use of tetronite in a lower row, where the material clearly goes away and it also maintains volume. This happens to be in an animal, this happens to be in a rabbit, but obviously most of these experiments first have to prove the concept and prove the safety in animals before we can go to humans. The row on the top is a conventional bone void filler, which is called Hydroset, and it's not resorbable. Go on to the next one. The opportunity that exists for use of this material is primarily at this point being pursued in patients who are in need of an implant. And we have used the population of patients in our human study, which is underway now. And those patients have a failing tooth that they're about to lose. And that socket from the tooth is too large to place an implant in it. And about 56% of implant patients, according to our surveys, are in that situation. Another 44% need to have a tooth replaced where the tooth is already missing and healed. We can use the material in both situations. It turns out also that about a third of all of the grafting patients who require grafting require more than one session of grafting, and we are hoping to obviate the need for that by having a material that maintains volume better. I believe you're going to be next, Dr. Gracia. Go ahead.
Okay. In this way, I'm going to show you that this material, in the way that we practice in our dental office in January, we see patients that come with different emergencies. And for us, we would like to see a material that you can utilize it and use it immediately after the tooth is extracted. I'm going to show you here 3 stages of how the procedure is done. The standard of care, the tooth is extracted, you clean the socket, you put a membrane, sometimes you use tacks, you suture it, you wait 4 to 6 months, and then after that, you may use a surgical guide, or you must stay free-handed, place the implants, then you wait another 2-3 months to put the crowns. With tetranite, that is a desirable characteristic, and this is a non-metallic material. It's osteoconductor, resorbable, injectable. We can review the bone and install the implant crown at the same time. That's the benefits of this material. Accelerate treatment flow faster, return of the function, and eliminate a surgical procedure, reduce the postoperative pain, and reduce risk for infection. This is our dream material that we're looking for. Who can be bien fuerte, en la cual you can soportar la aplicación de la carga inmediatamente. Es un material ideal para nosotros los cirujanos o odontólogos ideales que se nos presenta esta oportunidad con este material sintético. Como decimos anteriormente, es osteoconductivo, reabsorbible, inyectable y produce osteointegración. Es muy fuerte para la aplicación de carga y es un estabilizador del implante. I want to show you here the packaging delivery concept, la forma en cual se ha desarrollado el delivery de este medicamento. El device es un triturador como de una amalgama y se coloca la cápsula con el aplicador y se pone en el triturador. Una vez está ahí, aproximadamente 5 seconds, saca el material y el siguiente video. En este video se puede mostrar si hicieron 3 concavidades en un material en el cual se pone la mezcla y una vez está listo, en 12 segundos se coloca en el aplicador de jeringa y se desarrolló una tip como una puntica de plástico circular que va a ayudar a que el material sea líquido y inyectable fácil para llenar todo lo que es la cavidad donde se va a colocar el implante. George?
Yes. As you can see, the material can be injected into the socket left after extraction of a tooth, and that has very little stability. But in terms of implants who are extracted, of sites where the implant is being placed into a newly developed osteotomy, you may be familiar with this graft, where primary stability, which is frictional stability of the implant in the socket, generally drops off at early weeks. And it isn't until after that that the deposition of bone starts developing the secondary stability of the implant through osseointegration. And so techniques have been developed by different manufacturers to shift or eliminate the dip. But the dip still exists because bone is slow, osteoblasts are slow to deposit new bone on the implant. And the primary stability, which is frictional, is diminished by the beginning of remodeling of the bone that held the implant, and that caused the dip. What we have with tetranite is We glue the implant in, literally, into the socket, and there is no dip because the material, in essence, accomplishes integration at time 0. And we have evidence to show that this does not diminish in a clinical sequence from week to week. It remains the same. In fact, if you go to the next slide, here are some data, some results from an experiment that we did with tetranite. We monitored the presence of the dip by using Astel technology. If you look at the graph, you'll see that approximately at 55 ISQ, there is a red line. That is considered the clinical stability threshold, so to say. And all the data points above it come from several implants in 3 different animals. Altogether, I believe there were 6 different implants. And you'll notice that none of them, at no point does the ISQ dip below the amount that's considered clinically stable. And it continues without a dip from the beginning, where we had the ISQ of approximately 70 until 30 weeks later, which is 9 months later. This kind of data we all have also found by reverse torquing the implants at specific times destructively. This obviously was non-destructive. It was in living animals. Go ahead, go to the next one. The the photographs shown here are of an animal model where implants were placed into one of the sockets. These are all premolar sites from a canine, and the one of the sockets has an oversized osteotomy and an implant placed into it with tetranite, and the other socket is simply filled as a ridge preservation graft procedure, but not sutured. And as you see, from immediate post-op to first week, the tissue heals over the site. In fact, it heals right over the exposed tetranite. That's approximately a 4 millimeter by 4 millimeter area that's exposed. By week 2, the tissues have totally healed. We've put healing abutments on, and you can see healthy tissue. At week 3, 5, and 8, I've taken the healing abutments off to show excellent healing and very little inflammation associated with the presence of the material. And likewise, all the way out to week 10, at which point we have some histology to show you. Go ahead. Next. Actually, this is from a different animal, but what you can see is on the left, a bright field photomicrograph, and on the right is epifluorescent photomicrograph. The material, TN, tetranite, is fluorescent somewhat. So you can see the outline of the implant on the right, and on the left, you simply see it as black material on the surface. But one thing that you can see is that by 9 weeks, there is substantial amount of new bone deposited onto the tetranite as well as the implant. And that is, the new bone is NB with the blue arrows. That is amazing in terms of what we've found with other materials, other bone graft materials. This material is resorbable, but it also becomes osseointegrated very early after the procedure. Go on to the next slide, please. In fact, if you look at this slide, this is 10 weeks post-implantation, and those of you who do clinical implant dentistry know how critical the area at the shoulder of the implant is at the permucosal site in terms of both inflammation and bone loss. This is a it's a collage of several photomicrographs to show the entirety of the outline of the implant. But If you look where the red box is, that is the area where there is approximately 1 millimeter of tetranite between the bone and the implant surface. The original osteotomy is marked with the thin blue arrows, and the white dashed line approximates the outline of the threads of the implant. So what you're seeing in the little red box is gingival cuff from the superior. The buff color is bone. The black color is either the implant or the tetranite. And the grout line is about 1.5 millimeters or so exposed to the soft tissue. If you go to the next slide, you can see a close-up of what was in the red box. And you can see that there is new bone developing on the surface of tetranite, right in that critical area, the neck of the implant, and that there is no fibrous tissue penetrating the deposit. The material is solid. And I was shocked to see this phenomenon, but we have seen it in many cases, and you've also seen the reaction of the soft tissues. It is something that we see regularly with this material. Go ahead, next. Now, what this is also 10 weeks. Go back, please.
Yeah.
Okay. These are a series of photomicrographs, also at 10 weeks post-implantation, and it just shows an area in a yellow box where the osteoclasts are removing remnants of fragmented tetranite. At the bottom of the box, the black box, is an area where the material is being dissolved away and resorbed, and wherever it becomes fragmented, as you can see in the red box on the right, there are giant multinucleated cells which break it up. We can go to the next one. This is 6-month post-op, and these photomicrographs show an implant that was cemented with tetranite into the osteotomy. You can see the implant, it's marked I. In these slides, red and orange are the bone. The darker parts of the stain indicate areas of newer bone. In other words, those are the places where the bone is the youngest. If you also look at the superior part on the left above the implant, apical to the implant, you will see that the osteotomy went beyond where the implant was inserted. And you can see the material still in there. But if you look at the yellow box on the top, it is the lower image on the left. You can see that there is mature bone past the apex and in between remnants of the tetranite in that image at 6-month post-op. And in the cervical area, which is the larger yellow box, and the image on the lower right, you can see the close approximation of the bone to the implant where tetranite initially was. As you can see, it is the darker bone, it is newly formed, and it has wonderful attachment to the implant as far as the bone level is. I think we can go to the next one. Now I'm going to show you a study that I have done very recently. It is an immediate placement of implants into sites that have been made overly large with an oversized drill. There are 3 implants placed there. This is in an animal. You can see the radiograph on the left and the clinical photograph on the right, showing the same 3 implants which have just been cemented in. We allowed these implants to stay in vivo for 4 months and then did some histology. Go to the next one. And this is what the photomicrographs look like, as well as a schematic of what the osteotomy was like. And you can see that the red, which is the bone, has penetrated right onto the implant surface and has been replacing the material. You can also see that there is bone over the crest, which has grown over the crest of the deposit of the tetranite. When we looked at, if we go back one, please. If you look at the implants, there are 6 different ones. I'm not disclosing what brands they are, but they are all different brands. They have comparable sizes, and they have very different characteristics of the surface and placement. Some have micro grooves, some are sandblasted, some are acid edge, some are tapered, some are straight, and so on. It did not make any difference. We can skip 2 now. Go to slide number 21, please. It did not make any difference in terms of removal force, statistically, which implant was glued in with tetranite. And here you can see 5 different designs of implants at 4 months post-insertion. And you can see bone replacing the tetranite, and you can see the contour preservation and bone level preservation that we so much want, especially in the aesthetic zones. And you can see that the first 2 on the left are tissue level, and the other 3 on the right are bone level implants. And this is from a study that hasn't been published yet. I don't want to show too much. We have a number of studies on the way currently, including one in humans. And we have also, go to the next one, please. We have also a study that will be shortly published in the JOMI journal, the International Journal of Oral Maxillofacial Implants, of which I'm one of the authors. And we will be presenting material from that study in September as well. Since it hasn't been published yet, I was not free to show you the results, but I can assure you that the results were very good. Álvaro?
Okay, now, and notice what we see the report of the Josh being presented. Many times we have patients come to our office with a tooth like this, we cannot restore it. There we go, this the whole way, we find out we have a little dehiscence, and we take the tooth out, we clean it out, we pack some bone, el diente se extrae, hay una fractura en la parte bucal, y entonces no se puede colocar el implante, se coloca hueso, you put bone on it, then you suture it, next. You temporize it with some medium bridges, you wait around 5 months, the patient come back, you place the implant, espera 6 meses, 5 o 6 meses, y el paciente coloca así el implante, yes. Y bueno, hasta que se cicatrice, se haga la integración del hueso alrededor del implante, haces el temporal, otro tiempo, otros 2-3 semanas después de temporización vas a tomar impresión, ¿ves? Colocas la palmen y haces la entrega de la corona. Un proyecto que se demoró aproximadamente cerca de 1 año. ¿Ves? El otro problema que tenemos es que se saca el diente, we take the tooth out, immediately after we take a good planning, we find out that the tooth is being able to be removed, we need an implant, using bone material around the implant. You temporize it immediately to keep the papilla and the tissue around it. Yes? Now you see, after you mature, creating the cuff for the temporary, continue please. You wait, and this is a temporary stage in the case. Yes? This is another case that we did. This is doing 3 cases. The first case was that you couldn't do the implant. No se puede colocar el implante, se temporalizó con un Maryland bridge, se temporalizó con un Maryland bridge. The second case was taking the tooth out, sacando el diente y colocando un implante con su temporal. This case is taking we did 2 cases here. One way, we do it the traditional way. Una forma se hizo la forma tradicional, como la segunda forma. Y en la que sigue, the next apartment, el number 8, el número 11, you can see the tooth was planted and take the tooth out. Everything we say, we done with the CT scan and 3D diagnosis technology, the digital flow, to make the one-time abutment. Aquí en este caso se coloca el implante, se coloca el abutment y se coloca la corona en el mismo cita de la appointment. Como se pueden ver, el manejo del tejido es muy diferente. You can see the management of the tissue is very different. We always push in the envelope to get the tooth immediately. Everybody today are busy. Everybody wants to have a tooth. Sometimes we can't do it. It's why these materials come very, very handy. This material is the best thing you can have. And for me as a surgeon, prosthodontics, I would say that it's completely changed the pattern shift of bone grafting material. Yes, you can see here in this case that I was showing you before, the one time abutment, we use a jig. We've done two different ways. The abutment is secure. If the day of the surgery is the implant and the implant is placed, the abutment is using the jig como una especie de guía para que quede exactamente como lo planeamos. Yes. Y se coloca el jig para colocar el abutment y después de eso se coloca la corona. ¿Ves? Ahí está la corona y el implante, dos son implantes y se puede ver el manejo del tejido. Ese fue el día inmediato que se colocó el implante. ¿Ves? This, now we go to use tetranide. This is the desirable characteristic material, and we wanted to use something that is biocompatible, biodegradable, and adherent to bone. That's tetranide. Es un material que es biocompatible y si es biodegradable, se absorbe en parte del hueso y podemos ver en este caso, el diente se sacó, se colocó el implante, se colocó el tornillo del corkscrew para asegurar el implante y se suturó en este caso y vemos cómo es el implante con el tetranide around it. This case was done by Dr. Mike Picos, who was our first doctor who did the clinical trial at his office in October. We just wanted to see the final crowd. But the main concept is here is how you can do this in one appointment. Even if the paperwork breaks, you can use tetranide around it using the disposable, using the material, the device that you can apply around injectable, put around the implant. You can literally clean it around it with some plastic instrument, don't have any tetranide over the implant. And you can leave it as the tissue a little bit exposed. It will create a secondary tension, leave it exposed. And the tissue will be very friendly. The tetranide will be friendly to the tissue and vice versa. And it will heal beautiful. I just want to say to everybody to be tuned to this. This is completely a big change in bone grafting. There's no need for use like titanium membranes or tags or screws. You can do it in this size like this. That is the concept. That's our goal with this product. It is impossible to be possible in a few minutes. Thank you. Thank you very much.
Thank you.
Any questions?
Excellent. Thank you both. Gracias a los conectados, gracias a los que están escribiendo, a los que están aquí conectados en las redes sociales. Les recordamos que esta transmisión queda grabada en los medios oficiales de Portal Odontólogos. This presentation will be stored in our media, in our official channels. Y para los que estuvieron viéndolo y no saben un poco de inglés, les recordamos que en YouTube pueden activar la parte de closed caption y trae como subtítulos y esa parte y trae la traducción. Entonces ahí puede ser ya con más comodidad, ya con más calma y lo pueden revisar. De igual manera, gracias al doctor Sergio Hiskin por invitar aquí al doctor Álvaro y al doctor George. Thank you, Dr. George. Él estará presente en el Congreso de septiembre de la AIOI. Gracias a todos los integrantes de la AIOI también por ser posible. Esto es en septiembre en Argentina y pues ahí están todos invitados. Vamos a ponerlos en pantalla de igual manera. Y no sé si quieran agregar algo a su presentación. I don't know if you want to add some to your presentation, Dr. George, Dr. Álvaro.
Well, I've pretty much covered everything that I could. I would just encourage people to come to the lecture in September because we are going to have material that is going to go well beyond what was presented here. And we're going to have some materials that are literally going to be right off the presses. In other words, they're going to be they're being developed now. You're going to see new material, both histology and clinical photographs, which don't even exist yet. It will be very new.
Yo le diría a todos los médicos que están participando en esta presentación, I would tell everybody who is part of this presentation, that this material, it will change your concept about any concept about EPA loading, de carga inmediata.
Ok, y funcionaría con cualquier tipo de implante, con cualquier marca, con cualquier, digamos que puede ser como universal, puede ser como un complemento al tratamiento, al procedimiento.
No hay diferencia. It works with everything that we have tried so far. We have used it with titanium-based implants, in other words, titanium and titanium alloys. At this point, we're not allowed to go to humans on the market except in the clinical trials. But on benchtop, in other words, in experiments in the laboratory, the material works equally well with metallic implants and with zirconia implants as well.
Ok, ¿y en cuánto tiempo cree que considere ya esté como disponible para todos los dentistas, para todos los implantólogos, para todos los que necesitarían utilizar este producto?
I believe it will be available in perhaps 2 to 3 years from now. But we are already conducting a human study in the stabilization material, the implant stabilization material, which will be complete a year from now. And depending on how quickly the regulatory process through the FDA proceeds, we may be able to have a product on the market a year after that, perhaps, but no sooner. So my guess is between 2.5 and 3 years from now, when it will be available to clinicians. However, we are going to be doing human trials, quite possibly including South America, so it will be tested in humans before that, but not in general dentist population.
Exacto. Bueno, sin duda un producto revolucionario, un producto muy interesante. Evidentemente, como comenta, ¿no? Ahorita hay que hacer algunas pruebas, bueno, pero en su momento será un producto excelente.
Sí.
Sí. Lo que ha demostrado este producto, bueno, todos los experimentos que ha hecho el doctor Case y el equipo de trabajo son excelentes resultados. Y pues más estudios y más trabajos se están presentando que se va a recolectar más información para poder presentarles a ustedes el desarrollo de este producto. Este producto va a ser algo que ustedes, como cirujanos, querrían tener en sus manos inmediatamente.
Exactamente. Muchísimas gracias. Les recordamos entonces en Rosario, Argentina, en el 2020, septiembre, AIOI. Muchísimas gracias. Nos mandan saludos desde algunas partes de aquí de México, algunas ciudades en específico, desde Chiapas, desde Tlaxcala, desde Ciudad de Hidalgo, en Michoacán. Muchísimas gracias nuevamente a los que se conectan. También gracias, doctores, por siempre mantenernos informados sobre lo nuevo en la odontología. Es un mensaje. It's a message from Carmen Fonseca. Muchísimas gracias. Y
Gracias.
bueno, pues les recordamos que a los que están conectados en Facebook pueden descargar su constancia dándose de alta en Odontoticket. Es una plataforma para generar accesos y comprobantes de asistencia a los eventos. Muchísimas gracias. También les recordamos que estamos en todas las redes sociales. Estamos en Facebook, en Instagram, en Twitter, en Periscope, en YouTube y en LinkedIn, que tenemos contenido distinto para todos ustedes. Y vamos a hacer entrega de los reconocimientos digitales. Nos mandan también saludos desde Monterrey, Nuevo León. Muchísimas gracias al doctor Álvaro Gracia, esto está en pantalla, y por su valiosa participación en esta sesión online, primer adhesivo óseo, y también al doctor George W. Key. Thanks for your valuable participation in this online session, primer adhesivo óseo. Thank you, doctor. Thank you, Dr. Álvaro. Thank you, Dr. George. It's nice to have you in this morning here in Sesiones Online. Thank you, everybody.
It was a pleasure.
Gracias a todos y nos vemos en la próxima.
Thank you very much.